Alright, so one of the key things that I want you to take out of this chapter and this class in regards to statistics is how to understand results. Now, the big idea here is that statistics, like I said in a previous section, looks at the collective, not the individual. All right? When we are looking at individuals, those are anecdotes. All right? And just using anecdotes to justify a statistical claim is one sort of a logical fallacy. We didn't talk about that in our logic chapter, but it is another type of logical fallacy. And when you're looking at the collective, using data beats anecdotes all the time. All right? It's always better to, when you're looking at the collective, when you're looking at the whole group, it's always better to base your reasoning on data rather than just on a personal story that you've seen. All right? So, statistics looks at the collective. All right? Now, when I say it looks at the collective, we have to understand what that means, all right? Because most of the time, data is going to flash by in the media or results of a study, and maybe it's a study on people who's smoking and linking to committing crimes. And so the headline would say something like, people who smoke are more likely to commit crimes. Now, I want you to understand what this is actually saying and what this is not saying. Okay? What it's actually saying... Oops. Can't do that. If you actually look at the results, is that they took two groups of people, those who smoke and those who don't. So we have a smoking set and a non-smoking. And maybe, I don't know, 8%, I have no idea what the actual numbers would be, but maybe 8% of those who smoke committed crimes. And those who didn't smoke, maybe that was only 5%. Or maybe it's even lower. Maybe it's, different result. Maybe it's 7% versus 6.5%. I don't know what the actual. It really depends on the study. So when you're doing statistics, oftentimes you'll get results like this. If you look at smokers and non-smokers, 8% of smokers commit crime, 5% don't. And so the result will say people who smoke are more likely to commit crimes. Now, oftentimes, those who don't understand statistics, all right, interpret that wrong. You'll see a lot of bad posts and really dumb posts on Facebook that is really sort of showing their lack of knowledge with statistics. All right? What we're not saying all people who smoke commit crimes. We're not saying 100% of these people commit crimes. Or we're not saying those who don't smoke never commit crimes. All right? We're not saying those two things. What results like this almost always are saying is that there is a difference in the proportions. But that difference is rarely a 0 versus 100% thing. All right? Also, what we're not saying that smoking causes crime. All right? all the results are saying is that those who are in the category of smokers have a higher percentage of committing crime. Those who are in the category of not smokers have a smaller percentage. We're not saying that the actual act of smoking is causing them to commit crime. That's a very different sort of statement. Okay? So we have to understand this in a variety of examples to be really good consumers of data and good citizens in general. So you'll often see things like a study will say you're more likely to have a disease if you do something, like for instance smoke, right? You may be more likely to have a certain disease if you smoke, or you may likely have a certain disease if you eat certain foods, right? Or you're more likely to have a disease if you carry a certain gene. Or, well, I already said eat certain foods. I guess that could be clumped in with do an action. Right? You're more likely to have a disease if you eat these kinds of foods. Right? And again, when we say that, even in the case of genetics, all right, even in the case of genetics, very often to have a gene and a disease, or even it could be a certain trait, for instance, like baldness, it works this same way, okay? So maybe, for instance, let's take the trait of baldness. There's actually a gene that's correlated with baldness. And when I say correlated with baldness, I mean you're more likely to have that, okay? And often people will call this the baldness gene. And if you look at the actual data, I don't know what the actual numbers are, so I'm going to make some numbers up. Those who have the gene, well, let's just say, again, I'm making these numbers up, about 40% of them have the gene. Or excuse me, 40% of those with the gene actually are bald. All right. Those who don't have the gene, maybe only 10% of those people are bald. All right. So even in genetics, there are oftentimes cases where this is not a 100% versus 0% thing. Now, there are genes like that, okay? There's, for instance, something called an SDRY gene, and it's the gene that determines whether you're male. If you have this gene, you're male. So that's 100% versus 0%. But the genetics, in a lot of cases, are not 100 versus 0. You know, they're 40 versus 10. Or maybe, again, the baldness gene, I don't know. Maybe one's 100 and one's 10. Or maybe one is 40% and one's 0%. But the point of this is that almost always nothing's 100 versus 0%. All right, just like in a famous case, we know, well, most of us should know by now, that if you smoke, you're at a higher risk for lung cancer, all right? And cancers in particular, and lots of other diseases, all right? So that does not mean, that is not saying that 100% of people who smoke will get those diseases, all right? It's just saying that you are more likely. Now, I don't know the actual percentages, but hopefully most of you know that, again, if you smoke, you're more likely to have certain diseases. It's not 100% guarantee that you're going to have these diseases, but you are more likely. All right? I talked about genetics, and you can click on this website if you like, or just type it into this website. This is genecards.org. It shows you a lot of different genes that are linked to things maybe like diseases, linked to things like this. And some of the genes might be 100 versus 0%. Some of them might be 100 versus 40%. Some of them might be 10 versus 0%. All right? And you have to understand sort of the difference between a certain gene being a, 100% of people with the gene versus 0% of people without the gene have a certain disease, or if it's a situation where it's, let's say, 40 to 2%, or if it's a situation like 40 to, let's go slightly under because this one was going 39%, right? If we're in a situation like this, then I should really be concerned about that gene. Probably I should also be concerned about that gene in a situation like this. In a situation like this, probably not too much concerned about it. In a situation like, I don't know, 1% versus 0.5%, whoops, let me rewrite that. That's 0.5%, so half of a percent. Right? I probably shouldn't be really concerned about it. And you'd be amazed how much fuss comes out of these last two cases. All right? A lot of times people aren't smart enough to sort of look at the actual percentages behind the differences of the two groups. People with the gene versus without, or people who do a certain action, right? If lung cancer, and probably more likely lung cancer with smoking, is in the 40 versus 2%, then that's something you should be concerned about if you smoke. If it's in the 0.5 versus 1%, that's probably not that concerning. Lung cancer is, I believe, somewhere closer to this one. All right. I don't know that for sure. Now, here's where it kind of comes back down to you. I've been talking about smoking. I've been talking about genes. Most of us probably don't even know our genetic structure, but we do know family histories and things of that nature. But one thing you'll see here on TV is medication warning labels. And you'll see, medicine for some sort of allergy. Let's say we have allergy medicine. And it'll say side effects include. And then list a bunch of side effects, right? Maybe your allergy medication, faintness, dizziness, shortness of breath, headaches, stomach aches, bowel problems, I don't know. There's all kinds of side effects that you can, you've seen the commercials for the side with all those side effects that are kind of scary if you actually listen to them. But what's important about these side effects is really not just whether they exist or not, but what's the percentage of frequency that they occur. If I have severe allergies, and the side effects only happen to, again, let's go real small, 0.5% of people. So 0.5% of people, side effects, it's probably worth the risk of those side effects to try that allergy medication. If those side effects happen to 50% of people, so half of all people who take the medicine, then you might hesitate to actually take that allergy medicine. All right? And a thing to know about side effects is usually they happen to a very small percentage. Maybe, again, I'm not saying they happen to 0.5%, but it really depends on the medications. All right. And even if, let's go to the worst case scenario. Side effects include. Well, I'm not saying I guess this is the worst case, but let's say side effects include death. All right. Well, that's a really bad side effect for most people. You have to determine whether these percentages are worth it to reduce your allergies, right? Or let's go to another scenario. Instead of allergy medication, here's one that was in the news recently, at least a couple of years ago. There's something that's known as female Viagra. Now, this is actually not approved yet, or has not been approved as of 2014, but it is not. Let me say this: the FDA, Food and Drug Administration, stop medications coming online that they deem could be harmful, and this is one of those things. Something, and I don't know the official name for it, but it's called female Viagra. So females take it, and the same things for male Viagra. So, anyways, FDA stopped it because the side effects they deemed had a high enough percentage. Now, I don't know what the actual percentage of side effects were, but they stopped it. And let's just, for the sake of argument, we'll go somewhere in the middle. Instead of 50, we'll go, let's say 5% of people had some bad side effects. Let's not say death. Let's just say headaches. All right. So the FDA made the determination that this is a big enough percentage to stop this drug. Okay. And again, I'm making up these percentages and also the side effects. I don't know the actual side effects to this. But it does bring up sort of a moral issue. Who should actually decide which percentages cut off, for instance, a female Viagra, versus what percentages should be allowed with an allergy medication, versus what percentages should be allowed with a heart medication. All right? And so currently the FDA sort of weighs this percentage, the side effects percentage, and the danger, the percentage of people who are going to have dangerous side effects, with the actual usefulness of the drug, and they sort of make an assessment. All right? Whether that's the right way to do it or not, we can talk about on a forum or something, but that's what actually happens. So I hope that this kind of showed you, again, when you get your mind thinking about when you see those headlines, what those things actually mean. All right? If there's a significant difference, what is it? What are those underlying percentages that they're looking at?